Welcome to Stellar Insights, where we explore science's wildest, craziest stories that almost didn't happen. Today, I'm taking you back to what historians now call the boldest gamble humanity ever attempted. A mission so risky, if it were proposed today, NASA would need a 6-month review board. 6 months before they'd even approve the coffee budget for planning meetings. But here we are, in 1968, Cold War space race was at its fever pitch, and 3 American astronauts sat atop a 364-foot-tall rocket that, by modern safety standards, was basically an untested bomb with very expensive passengers. If you love science breakthroughs, engineering madness, and those, wait, they actually did that? Moments, hit that subscribe button and ring the notification bell. We've got Apollo 13 coming up next, which is basically the sequel to this disaster-averted movie. Today's story starts December 21st, 1968. 3 men on top of a firework that weighed nearly 7 million pounds when fully fueled. Their mission: escape Earth's gravity well and circle another world. Not land, just orbit the moon. But even that was absolutely insane for the time. Here's why this mission had to happen now. The Soviet Union was absolutely dominating the space race in 1968. They launched Sputnik first. They put Yuri Gagarin in orbit first. They sent Alexei Leonov on the first spacewalk, basically flexing their space credentials harder than anyone could have imagined. Then came September 1968 with shocking intelligence. The Soviet Saturn V spacecraft orbited the moon and returned safely, with 2 tortoises on board. Yes, real biological organisms had circled another celestial body before humans did. Now, you might think, tortoises? Who cares? But here's why that terrified NASA. If a turtle can survive a trip around the moon, so could cosmonauts. And Soviet intelligence suggested their next launch window opened December 1968, just weeks away from Apollo 8's scheduled date. NASA was in deep trouble at this point. Their lunar module, the small spacecraft designed to land on the moon, was having what engineers call teething problems, which is diplomatic speak for everything that could break was breaking. Wiring shorts, electrical fires, structural concerns. Grumman Aerospace, their contractor, said they needed 6 to 8 more months. NASA's answer? George Low, an executive who would later go down as the mission savior, suggested something radical. What if we just skip the landing module entirely? Fly to the moon without it, orbit once, and come home. The room went silent. Then someone asked the obvious question, "Are you serious?" Low's response, "Completely. And here's why." Now, let me talk about the actual machine that would carry them there. The Saturn V stands at 363 feet tall, taller than the Statue of Liberty from base to torch combined. Fully fueled, nearly 7 million pounds. To put this in perspective, that's roughly 12 fully loaded semi-trucks per second burning during launch. The real magic happened with those 5 massive F1 engines at the rocket's base. Each one consumed 48,000 gallons of fuel per second. 5 engines? That's nearly 500,000 gallons every single second for 2.5 minutes straight. The exhaust alone could power the entire state of Florida for hours. Here's where engineering becomes almost magical. Each F1 engine contained turbopumps generating 55,000 horsepower each, enough to lift a freight train 65 feet in 1 second. Inside those combustion chambers, temperatures reaching 6,000 Beard mash node, hotter than Venus's surface. Now, for the terrifying part, Apollo 8 was Saturn V's first crewed flight. The previous test mission, Apollo 6, had encountered something called pogo oscillation, violent vibrations that shook like a roller coaster on meth. Two second-stage engines shut down early due to structural stress. NASA added helium injection to the fuel lines as shock absorbers, but they'd never tested it with actual humans aboard. The third stage, SIBB, was even more nerve-wracking. It burned liquid hydrogen at -423 GORs, so cold that oxygen in surrounding air actually froze into solid ice on exposed surfaces. More critically, this engine needed to start 1C for Earth orbit, then shut down completely, drift through vacuum for hours, and start again for trans-lunar injection. Nobody had ever successfully restarted a liquid hydrogen engine in space before. Hydrogen expands unpredictably when heated. Fuel lines freeze instantly without careful thermal management. In the vacuum of space, physics behaves differently than our engineers expected. If Psi-B failed to restart, Apollo 8 would orbit Earth forever until their life support expired. Since they had no lunar module for emergency rescue, NASA designed what became one of the most ingenious solutions in spaceflight history: the free return trajectory. Here's how it works with beautiful Newtonian elegance. If their main service engine failed at the moon, gravity would actually bend their path into a natural figure-8 orbit that returned them to Earth without using any fuel. No backup system needed. Just pure orbital mechanics saving their lives. Think of it like launching a ball in such a way that if you miss your target, physics throws it back home anyway. The mathematical precision required was insane. Engineers calculated every decimal point, every kilometer. A deviation of just 0.1% meant one of three outcomes: crash into the moon, escape solar system entirely, or burn up during re-entry. For context, NASA's entire safety margin for this mission could fit inside a standard office printer drawer. Yet, it worked perfectly. This trajectory wasn't just genius engineering. It was the only thing keeping three men alive if anything went wrong. And remember, there were no emergency rendezvous points, no backup spacecraft waiting anywhere in their path. It was them, the moon, physics, and hope. December 21st, 1968, 7:51 a.m. Eastern Time, Cape Canaveral. The 5 F1 engines ignited in sequence, the loudest human-made sound ever created during peacetime. Jim Lovell later described it. After release, communication became impossible due to noise alone. The final words anyone heard from Launch Tower before radio blackout was a muffled "Tower clear" for 2 minutes and 43 seconds. Saturn V consumed nearly 2 million pounds of fuel, pushing the spacecraft through 68 miles altitude at speeds approaching 7,000 miles per hour to peaced awe. Stage after stage dropped into the Atlantic Ocean like expensive fireworks debris. They orbited Earth once, checking systems, breathing heavy. Then came the moment that would define everything. TLI burn. IVB engine ignition sequence began. If this failed, mission accomplished would be impossible. They'd orbit Earth forever until oxygen ran out. Apollo 8's computer counted down in silence. 3, 2, 1, main engine ignited. They accelerated by nearly 2 miles per second, breaking free from Earth's gravitational dominance. For the first time in human history, 3 astronauts were traveling toward another world without landing gear or backup rescue vehicle. Frank Borman's exact quote, "This is going to be a wild ride." He wasn't wrong. Now for the long haul, 3 days floating toward lunar orbit at roughly 7 miles per second. But space travel comes with its own set of problems that don't appear on any flight manual. The first? Temperature extremes. Sun-facing side reached plus 200 degrade Fahrenheit. Shadow side dropped to minus 150 degrade Fahrenheit differential across the spacecraft could crack metal, burst seals, or destroy instruments. Their solution? Barbecue roll. The entire spacecraft rotated once every hour like meat on a rotisserie, distributing heat evenly around all surfaces. Navigation in deep space required something that sounds prehistoric today. No GPS, no Google Maps, no satellite guidance. Instead, Jim Lovell used an actual sextant. The same instrument 18th century sailors used for navigation across oceans, to sight stars like Sirius and Canopus, plus Earth's horizon. This data went into their Apollo guidance computer with just 4 kilobytes of RAM. For comparison, your smartwatch has thousands more times that memory. Yet this tiny computer had to calculate life or death trajectory corrections with absolute precision. One wrong calculation by a few meters meant they might not return home at all. Meanwhile, Frank Borman experienced something NASA wasn't fully prepared for. Space adaptation syndrome, space sickness in its worst form. In zero gravity, your inner ear's vestibular system gets completely confused about which direction is down. Your brain doesn't know how to interpret sensory signals anymore. The dangerous reality: if an astronaut vomits while wearing a sealed spacesuit, they can drown from their own fluids inside the helmet. NASA was essentially learning this lesson in real time with human test subjects. Exactly the kind of scientific approach that modern safety regulations would never allow today. 69 hours after launch, Apollo 8 approached lunar orbit at roughly 1.5 miles per second. To be captured by the moon's gravity instead of flying past it entirely, they needed to slow down by about 2,000 feet per second. This was called low burn, lunar orbit injection. Here's what made this terrifying. It had to happen on the far side of the moon, behind lunar mountains that blocked all radio communication with Earth. No telemetry data streaming back, no ground control monitoring engines in real time. No one knew if they were making it or dying silently. Mission control could only wait, count minutes, hope. If the engine failed to ignite, they'd fly past the moon into deep space and never return. If it burned too long, they'd spiral downward and crash onto lunar surface. Too short? Wrong orbit, possibly stranded forever. Apollo 8 disappeared behind the moon's horizon. The spacecraft radio went dark for everyone watching on Earth. Mission control sat in stunned silence while millions of people held their breath across the globe. 4 minutes passed. 4 of the longest minutes in human spaceflight history. Then, Houston, Apollo 8, engine burn complete. We are now orbiting the moon. The control room erupted. 3 humans were now officially the first in history to orbit another celestial body. They'd also become the first to see the moon's far side with naked eyes, a place humanity had never photographed or visited before. Over 20 hours of lunar orbit, they completed 10 revolutions at roughly 70 miles altitude. But something strange kept happening. The spacecraft's orbital path wasn't behaving mathematically as expected. Sometimes it would drift lower without engine burn, other times gain unexpected momentum. What they discovered became crucial for future moon landings. Mass coni, mass concentrations of unusually dense material beneath lunar Mars regions, what we call seas. These created gravity anomalies that tugged spacecraft like invisible potholes in space. Computer readings might show 70 miles altitude while actual position was 68 miles. For Apollo 11's landing calculations, this data proved absolutely essential. NASA used these measurements to plot exact touchdown coordinates within feet of their target. Then came the moment that would change how humanity views itself. During Orbit 10, as spacecraft rotated past lunar horizon, Earth appeared. A bright blue marble floating above dead gray landscape. Bill Anders captured what became history's most influential space photograph. Earthrise, His exact words afterward: "We traveled to explore the moon, but discovered something far more important, that we're actually one planet, one home, one fragile ecosystem in infinite darkness." For billions of people watching Christmas Eve broadcast, this single image fundamentally shifted global consciousness. No borders visible from lunar perspective, no flags planted on surface mattering at that distance, just a green-white sphere suspended in black ocean. After 10 complete lunar orbits, it was time for what NASA called the tie-burn, trans-Earth injection. Once again, they'd fire their main engine on the far side of the moon with zero communication with home base. No one knew if their spacecraft would make the journey back. Christmas morning, 1968 at 1000 ION AM Houston time. Engine ignition sequence began. Jim Lovell's famous quip afterward captured both relief and humor perfectly. "Houston, report to the world that there is a Santa Claus after all." 3 days of coasting brought them back toward home at roughly 7 miles per second, approximately 25,000 miles per hour. At these speeds, kinetic energy becomes genuinely dangerous when hitting Earth's atmosphere. Their re-entry angle had to be exactly 6.4 degrees. Go steeper than 7 degrees? Crispais relieed 19.0 kinetically dangerous when hitting Earth's atmosphere. Their re-entry angle had to be exactly 6.4 degrees. Go steeper than 7 degrees, G-forces would crush their bodies and heat shield would burn through entirely. Go shallower than 5 degrees. They'd skip off the atmosphere like a stone across water, escaping into deep space forever. The Avcode heat shield material literally burned away during re-entry. Sacrificial protection reaching temperatures near 4,200 per sparing in Andy. Halvan Ju-es in what they stayed at the Horde Age crease. They trod ass to 6 mated broid and yep, approximately 1.5 miles from USS Yorktown aircraft carrier. They'd returned safely after spending more time traveling to another world than most humans spend on any single vacation. Apollo 8 brought back no moon rocks or lunar samples, but what they returned with mattered far more to future exploration. Gravitational anomaly maps of the entire moon proving landing sites could be safely calculated within feet rather than miles. Navigation techniques confirming humans can orient themselves in deep space using only stars and computers. First comprehensive data about human psychological response during extended deep space travel. Isolation, sleep deprivation, stress responses at 400,000 kilometers from home base. Saturn V's crewed flight confirmed. Pogo oscillation issues had been solved through engineering modifications. The service propulsion system proved capable of multiple restarts under extreme conditions. Critical capability for future lunar landing missions requiring orbital insertion and departure burns. Without Apollo 8 data, Apollo 11 would have faced significantly higher landing risks. Their guidance calculations, thermal testing results, and human performance metrics became the foundation upon which successful moon landings were built. Looking back, Apollo 8 represents one of history's most audacious decisions. 3 astronauts launched on an untested rocket without backup rescue vehicle. With only 6 weeks preparation time, traveling 250,000 miles into deep space to orbit another world and return safely. By today's safety standards, this mission would never receive approval from any review board. Too risky, too rushed, absolutely insane by modern metrics. Yet, in December 1968, humanity did exactly this. Not because they were reckless, but because they believed in mathematics, trusted Newtonian physics, respected engineering calculations, and understood that some moments demand action despite uncertainty. Frank Borman, Jim Lovell, Bill Anders, weren't showing off or taking unnecessary risks. They calculated every variable, understood consequences of each decision, and accepted responsibility for choices made with full knowledge attached. Sometimes in history, opportunities appear only once. If you don't seize them, they vanish forever. Apollo 8 proved that with precise calculations, courage, and a touch of necessary madness, humanity can transcend perceived limitations. The Earthrise photograph fundamentally changed how we see ourselves on this planet. First time anyone viewed their own world from another place. First time realizing how small, fragile, and precious our home actually is against infinite cosmic darkness. Perhaps that's Apollo 8's greatest achievement. They left to explore the moon, but discovered Earth instead. And in doing so, changed humanity's perspective on itself forever. And that's the story of Apollo 8. Humanity's craziest, boldest gamble in space exploration history. If you enjoyed this deep dive into science and history, smash that red like button below. It genuinely helps us reach more people. Subscribe to Stellar Insights if you haven't already, and hit notification bells so you never miss our next scientific adventure. Got questions or topics you want us exploring? Drop comments below. We read every single one and actually respond when possible. Next time, we're tackling Apollo 13, the successful failure story that proves science, quick thinking, and teamwork can turn disaster into triumph at exactly 400,000 kilometers from home. Don't miss it. This is Stellar Insights, where science becomes thrilling and absolutely worth exploring. Thanks for joining us on this insane journey through history. Until next time, keep looking up, keep questioning everything. And remember, sometimes the most important discoveries happen when you dare to try the impossible.